All right. So the next we have capacity decisions. What is your capacity? And so capacity is the maximum capability to produce your product or service. And for machinery, there is rated capacity, the theoretical maximum. If I ran this machine at full speed all day long for an 8-hour shift or 2 8-hour shifts, 16 hours a day, how many units could it crank out? Well, you always have shift turnover, you have maintenance checks, you have quality control checks, you have all kinds of things, problems, defects that are manufactured, you have to go back and rerun. So your actual capacity is never going to be the rated or theoretical capacity. Assuming nothing ever went wrong, nobody had to do any setup, you're just at full maximum speed all the time. Now, in some machinery, some situations, you can get close to rated capacity. It also depends on how conservative the rating is. Most manufacturers want to push that rating up kind of high. Other manufacturers might want to be a little bit conservative on the numbers and say, no, we give you a number you can really run at, rather than something that if you really crank it up and you're willing to handle some defects, we can run it at this speed now. Um, anyway, so what you really need to come up with is the effective capacity. And effective capacity includes the efficiency. So it takes out any defects, it takes out any setup time or downtime. And then utilization. When are you not running it? If you're only using a machine that can do, let's say, 10,000 units a day, but you're only using a day, an 8-hour day, 10,000 units in 8 hours, but you only run that machine for 2 hours a day, you're not going to make the 8-hour capacity. You're only going to make the 2 hour effective capacity because you're not utilizing that machine as much. And, there are lots of decisions in agriculture. I know I talked about the strawberry trucks. Well, if you got problems with strawberry harvest trucks and renting them or leasing them during harvest season, why don't you just buy your own trucks? Well, if I buy those trucks, I've got them sitting all winter long, not doing anything. And part of the spring, I'm using those trucks from, Valentine's Day through uh, Halloween or something. And the rest of the year, they're not doing anything. Is that a good use of the money? Should I own my own trucks or should I lease them? Now, that is a capacity and a utilization issue, but it's not the type of manufacturing machinery capacity that I'm talking about here. I'm talking about how many heads of lettuce can the slicer slice per hour? How many 1 pound bags of garden salad can the Hasten machine bag per hour? Things like that. Capacity utilization, what is the percent of available time that you spend actually working? And, that has to look at different situations. You might be a company that runs 8-hour shifts or 8 hours a day. You're on for 8 hours, you work the 9 to 5. In manufacturing and food, you often run 2 shifts. You have your morning shift that starts early in the morning, the swing shift, which runs late afternoon into the evening, late evening. And then the graveyard shift is the cleanup shift or the maintenance shift. You come in, you sanitize, clean up the equipment, oil, lubricate, inspect, you make sure everything's clean, sanitary, and ready to go for the next morning shift. So 16 hours of production, 8 hours to prepare for the next 16. So what is your time? And out of that, let's say you are a 16-hour production operation making bagged salads. Out of that 16 hours of production, how many hours are you actually spitting out bags out of your line at a full capacity rate, at least an effective capacity rate? And it's not all 16. Again, that you have to get the new people in, you got to load the correct film with the right labeling on the line, you got to set information if you're printing anything, barcoding or expiration dates, you got to set all that up, you got to check the scales, you got to calibrate them, you got to check that the metal detector is working right, and by the time you get set up, you burned some time. Now, if you overlap some of that time, if you're very efficient, you might have some of that done, and so your loss of production, once the production run is going, maybe it only takes you 15 or 20 minutes, and you're going. Maybe less, maybe more. Maybe there's a whole hour of a certain type of manufacturing that is set up, and you're not running the machine at capacity. So you have to look at the percent time, and it's different for different types of machinery, different types of industries. What about the efficiency? How well does a machine or a worker perform compared to a standard output level? So you have to look at that. And there are differences from machine operator to machine operator. They aren't all identical. Some people pay attention more, they keep things working more efficiently, they get set up faster, they avoid downtime with defects because they're really on it, they're paying attention, they're good. And then there are others that don't, they're not as experienced or as efficient. And it's not just the people, it's also machine to machine. Some machines are faster than others. What about capacity load? That's your standard hours of work assigned to the facility. And I talked about that. I didn't give it the name a moment ago, but I did talk about the hours. Is it 8 hours, one shift? Is it 16 hours, 2 shifts? Are you doing 3 shifts and running 24 hours? You've got toilet paper coming off that line 24 hours a day. And maintenance is cycled in a very quick and very minimal type of impact on production runs. And I know there are some examples of that. I know that there are companies that run certain types of products for the first 2 shifts, and then they do other products on the graveyard shift. And there was a story, I'm giggling a little bit because there was a story about some manufacturers in China, and they were doing the legal and international trade products that they did for 16 hours a day, but the other 8 hours a day they were doing knockoff purses and bootleg CDs and everything else in these manufacturing facilities during the shifts when they weren't being inspected. So they've got a whole different issue with their capacity load. They're making a little bit of extra money on the gray market areas after hours. And then capacity load percent. What's the ratio or the percentage between the actual load to capacity? So what percent are you utilizing? So again, don't get caught up in remembering the details of this. I think it just needs to be understood. What is my capacity? And it's related to how fast the machines can go, how fast the workers can go in a reasonable way, minus any setup time, et cetera, based on the hours of operation at your facility. So now if you're going to change capacity, you're going to expand capacity, you need to think things through, and there are different strategies for how to do that. And you should know these 4 diagrams. These graphs are relatively easy to understand, and you should know these 4 graphs. Capacity lead strategy. If you've got a good product, you know you've got sales, you know you're in a growth market, you see product demand growing and keeping up with your ability to sell it, you do capacity as a lead. You increase capacity ahead of demand. There's some risk to that, obviously. So if this black line, this diagonal line is the demand, and you see the demand going up, you increase the capacity to meet future demand. And as your demand reaches your capacity again, you add a new line, you add a new machine, you add capacity for the future. An obvious advantage to capacity lead is you always stay ahead of your customers. You always have product. You're never saying, I'm sorry, we don't have enough. We can't sell. You'll have to wait 2 months for the next order. You're always ahead of it. The disadvantage is you're taking a risk. If demand decides to flatten off and you just spent a bunch of money increasing capacity, you're going to have to eat the cost of that increased capacity, of the building expansion, of the machines you bought, whatever you spent on. If demand flattens out, you already spent the money. B is capacity lag strategy. So that's just the opposite thinking. And you're basically looking at demand and saying, I'm sorry, we don't have enough. We can only sell you X number of units, not X plus whatever. We don't have capacity. And so you sell what you can. And once you get to the point where demand has outpaced your capacity to supply that demand sufficiently, then you bump up your capacity to produce product to meet the demand. And so you're keeping your customers hungry. You're keeping them wanting. And that can be advantageous. The advantage, if you can keep supply limited, what's that story about supply and demand? If supply is limited and demand is high, prices go up. The disadvantage, if you aren't meeting demand, somebody else comes in and steals your lunch. Somebody else comes in and says, well, company A doesn't have it. We got it. We'll sell it to you. And they can steal your customers away. So you have to be really careful when you're going with a capacity lag strategy. If somebody else can step right in and fill that demand and take away your customers. So you've got to really know your market and understand the risks and benefits of a lead and lag strategy. They are different ways of looking at the market, different types of risk. You might not have the ability to do a capacity lead strategy. You know, maybe you're a cabinet shop and you're making cabinets and there's orders coming in left and right and you have to turn down orders. Oh, well, you can't expand until you make enough money. You can't spend the money ahead of when you have it. So you have no choice but to do the capacity lag strategy. And maybe you're not worried about it. You're a really good craftsperson. You've got really good staff. You've got a good reputation. People are wanting your cabinets. They want your product. And if they can't get it, they'll be happy the next time they're doing another house, and that contractor will be there going, awesome, you can take this job. Awesome. I need, I've got, $60,000 worth of cabinets for this custom home. Help me out here. And no, that's not an excessive number for some large custom homes. Cabinets are expensive. And yes, you can spend what might be considered a third of the cost of a house on cabinets. Anyway, then there's the average capacity strategy, C. And the average capacity strategy is just balancing. You're playing both sides of the equation. You're going to wait until your demand exceeds your capacity, but you're not going to wait too long. And then when you do increase your capacity, you're going to increase your capacity not to meet demand, but to exceed demand a little bit. And so you're kind of playing off both sides. So you're not overspending in advance, like you might with the capacity lead strategy, taking the risk on demand flattening off or crashing, and you're not risking too much with the customers being unhappy that you can't supply them as you might with a capacity lag strategy. You're just balancing capacity average or average capacity strategy. And the last one is the incremental versus the one-step expansion. Incremental is what we've been looking at in these previous graphs, where you jump up, you add a new line, you add a new machine, you just add a new worker, hire one more craftsperson or whatever. And you're just going up step by step by step, and it's increasing in increments. But the one-step expansion is when you anticipate a large demand in the future coming up, and so you build a whole new facility. You could think of it as a regional operation. So for example, when Fresh Express started, they were in Salinas and they had a seasonal operation in Yuma. They moved back and forth. Now they just stay put in Salinas. But at one point they said, you know what? We're going to open a facility in the South. We're going to open a facility in the East. And they did. And they opened up these whole new facilities to supply regional customers, to change the whole transportation profile. Now they're just transporting lettuce and cabbage and the raw products to the plants, but the finished salads are being shipped from regional locations. That's a huge one-step expansion. We're going to open a whole new manufacturing facility in Atlanta. That's a big deal. That's a lot of money, huge change in capacity, and it needs to be looking at a very optimistic future demand market in order to justify that kind of expansion or expense. But in a lot of markets, it makes a lot of sense. So capacity increase depends on a number of factors: the volume and certainty of anticipated demand. How much do you expect demand to change, and how certain are you that demand will go up? You don't increase capacity unless you have confidence, certainty that the demand expectations are going to meet your capacity decisions, at least in some reasonable length of time. That reasonable length of time, depending on what you're talking about, might be 3 months, it might be 3 years, but your numbers, your financial numbers, have to support that anticipated demand change. You have to be able to afford it and make it profitable. Strategic objectives. Maybe you're a small, and I keep using cabinet shops and salad plants because it's easy to picture these, but I don't want to be a mass-produced cabinet shop. I just want to make high-end cabinets for repeat customers, the contractors that keep coming back. I've got 3 craftspersons and 1 shop, and I don't want any more. Maybe I'll add another employee, but I don't want to grow into something too big. Well, that strategic objective isn't there. I don't want to chase more demand past some certain point. This is my strategic goal. I don't want to go past that because that's where I'm comfortable. I'm making enough money. I'm keeping happy. I don't have to worry about demand issues. I know I can keep my operation busy. Another company, it might be very different. You want to dominate the market. You want to grow until you squashed your competitors. What are you trying to do? What is the cost of the expansion? What is the cost of operating that new piece of equipment or new facility? So what's the best operating level? Well, that's the percent of capacity utilization that minimizes unit costs. So you might think that, oh, well, running at 100% is always going to be the most effective, and that's not true. Running at 100% often causes maintenance problems with your machinery. It causes mistakes to be made, defective products that need to be reworked or thrown away. There's all kinds of problems when you're running at too high a percent. And you can't make any adjustments. If I'm running at 80% normally, and I get a special order coming in that one of my really important customers wants some new order, I got that extra 20%. If I need to occasionally, I can throw a little extra overtime or something at my production line and meet that demand. If I'm at 100%, I have no excess capacity with which to meet new opportunities. A new customer, an existing customer that wants something really important, some really good opportunity, a sale. You know, you've got an opportunity to go with Kroger Market and they want to do some really special promotional sale on strawberry shortcakes, and you just can't supply any more strawberry shortcakes for their special sale. What are they going to do? Maybe they're going to go to one of your competitors. Capacity cushion is what I was talking about here. How much capacity is held in reserve for unexpected occurrences? And that can be the good things that I've been talking about, a new order, a new customer, an opportunity for some promotion with a client, all kinds of different things that could be good things. It can also be bad things. Somebody calls you up at 2 a.m. because your product arrived in New York defective. And now you need to do a rush order to get them new product right now. So what are you going to do? If you have zero capacity cushion, you either have to say, sorry, we can't do that. We sent you bad stuff. Too bad. Wait for the new stuff. That's not good. Or you have to tell some of your other customers, well, we've got an important customer that really needs this. We did a problem and we're going to have to hold back on your order. That doesn't look good. Having a little cushion to deal with defects, reworks, problems, all kinds of things go wrong in the real world. And having a little bit of cushion is never a bad thing. The next item is economies of scale. In general, it costs less per unit to produce high levels of output. So that first pencil that I make might cost me, $8,000. That first raft that I make might cost me $10,000. But if I make a whole bunch of them, I no longer have the setup costs, and the costs go way, way, way down to the point where if I'm doing something in mass production or continuous production or large scale batch production even, the cost per unit, per item comes down. It's cheaper. The main reason is that fixed costs can be spread over a larger number of units. So if I buy a machine that costs me $10,000 to make rafts, and I make 3,000 rafts with it, well, I bought a $10,000 machine to make 3,000 rafts. Did I make some money? Yeah, but if I use that same machine to make 25,000 rafts, that machine is still making me money and I didn't have to buy a new machine. There's some ongoing maintenance costs on the machine. Certainly have to lubricate it, replace bearings or whatever, seals and things that need to be checked periodically, but overall that machine can keep going for a long time. You need to know what that long time is. What is the life expectancy or the unit output expectancy of the machine you buy? But you can still spread that over larger number of units. Your fixed costs, if it costs $10,000, it's certainly cheaper if I can spread that $10,000 across 25,000 units rather than $10,000 across 3,000 units. The fewer units I make, the more each one of those units has to absorb the cost of that piece of machine, that fixed cost. Production or operating costs do not increase linearly with output levels. So if it costs me $5 to do a raft or $2 with this new fancy machine, well, with better training, better efficiency, a really good high output operation, without changing my fixed costs at all, I might be able to get that down to $1.80. I might be able to save some money, just trim a little money off because I'm more efficient when you're making larger numbers of output. Not always the case, but certainly in manufacturing environments, that is generally true. There's also quantity discounts. I mentioned that in the beginning of this presentation, but I'm buying materials. I go to somebody and say, I need 1,000 pounds of plastic beads. Fine, I'll sell you 1,000 pounds of plastic beads. You don't get much of a discount. That's not a huge amount of plastic beads. At least for manufacturing, it's not. But I go and I say I need 800,000 pounds of plastic beads for this next year, and you set up a contract, and you're going to be cranking out large volumes of toys or bags or whatever. You're going to be making Ziplocs or something. You're going to be going through a lot of plastic beads. And they're willing to sell you at discount because of one transaction with one overhead, and they made a bunch of money. They'll give you a discount rather than all of the sales and trying to get the customers, billing those customers. It takes a lot more effort to make $1 million with 1,000 transactions than it does to make $1 million with one transaction. They give you a discount, quantity purchases. Certainly operating efficiencies also increase as workers gain experience. I alluded to that a little bit earlier, but here it's stated explicitly that workers get better. You do a whole bunch of repetitive things and people get good at it. But it's not always the same. There are diseconomies or bad economic consequences of scale as well. If you go above some certain level of output, you hit what's called the diseconomies of scale. You're too big for your britches, as they say, or you're so big you start to become inefficient. Diseconomies of distribution, where trying to distribute your product becomes highly complex, highly inefficient. There have been a number of things that have changed that over recent decades, where distribution systems have changed to the point where it's a moving target. There is no magic number for diseconomies of distribution. The first major player to massively change the distribution issues was FedEx. The individual who started FedEx wrote some paper on how it actually is more efficient to send all of your packages through Missouri, even if they're only going 20 miles away. What? That couldn't possibly make sense. But the distribution center concept that was started created an entire industry. Now we have all kinds of companies like Federal Express, UPS, etc. And the next step up, Amazon has fine-tuned and taken advantage of those companies' distribution systems. So that's moved the scale up. Doesn't get rid of it, but it moves the scale up. If you can improve efficiency of distribution, the number that you can reach before it starts to get too big is higher. Diseconomies of bureaucracy. Lots of companies have run into this. I've run into this in companies I've worked with. If you're trying to make decisions in a small company, you can make that decision over morning coffee and a donut at 6 a.m. and have that implemented by 8 a.m. If it's something that takes a lot of work, maybe by next month. In a corporation, in a large corporation, It's hard. You get so bureaucratic in this department and that department and training and rules, da 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 da. The bureaucracy starts to weigh you down. It's too hard to make decisions. It's too many rules, and you can't just get rid of the rules. You're too big. You need those rules. So at some point, what is too big? Diseconomies of confusion. And diseconomies of confusion is the interrelationships among the departments. It's how many different relationships are necessary, and it gets to be extremely complex to operate companies beyond a certain point. Diseconomies of vulnerability. Certainly, the bigger you are, the harder you fall, kind of a concept. You're vulnerable because of market changes. If I'm so huge that changes in the steel market or changes in the oil market can actually crush my company because I can't keep going. There are lots of vulnerabilities that aren't as obvious and global as the steel or plastics and gasoline and diesel markets, but those are pretty easy ones to envision. So here's an example of diseconomies of scale for a hotel. Now, is 500 the sweet spot? In this chart, it is. Is that really the correct number? No, there's a lot of math and data that goes into creating a graph like this. You have to look at the layout of your operation, how it runs, what you're doing in that hotel. But this is actually pretty good for some of the large scale hotels. This is actually a pretty damn good number based on real world stuff at a decent mid-range to higher end hotel. What happens as you are growing the number of rooms in your hotel operation? And I'm not talking about Marriott where you have possibly hundreds of locations or even thousands of locations. I have no idea how many Marriotts there are, probably thousands. But at a given hotel, under one management structure, under one set of operations for cleaning services, bellhop services, valet parking, and food, and all of these things. If you got 10 rooms, it's hard to make money. You're in a vulnerable situation. You start to get higher numbers of rooms, and it's a factory. You start getting past 250 rooms, and it's a factory of washing sheets, making beds, cleaning bathrooms, providing room service food, on and on. Everything is like a factory, and it gets extremely efficient, extremely cost effective, and profits go up as the costs go down, the cost per room. But at some point, when you start getting in this range of about 400 to 500, those savings start slowing down. You're getting to be so big, it starts to be a problem. And that sweet spot is somewhere in here, somewhere in the 500 range, where your cost per room to operate that facility starts to go the other way. And if you do research on a place like Las Vegas, you'll find out that all of these major hotel operations are based on this kind of concept. How many people can we get to stay comfortably, efficiently, keeping our cost per room low? But it becomes diseconomic past that. You start having the diseconomies on the previous slide, where it's no longer efficient. It's too bureaucratic. It has diseconomies of scale that start making it cost more per room. Now, I mentioned the diseconomies of confusion, and this is just an illustration that helps understand that. If you have 4 different things that need to interact. 4 different departments, 4 different people, 4 different whatever. There's only 6 linkages, 6 relationships between these 4. There's the 4 sides of the square plus the diagonals, 5, 6. But if I only go up by 2, my processes went from 6 to 15 linkages. If I go up another 2, 8, it went to 28 linkages. So the complexity gets really difficult in terms of these diseconomies of confusion between the different and people, organizations, communications within this operation. And there are ways to minimize diseconomies of confusion. This is not a business class, but at some point, you're too big. At some point, the diseconomies of confusion are a significant hurdle that adds to the cost, adds to the risk of your company's operations. And that's when it makes sense to maybe spin off certain things. Instead of having a 1,000-room hotel, have 3 hotels at about 350 rooms each, or whatever. Instead of having a company that not only writes the software and makes the hardware and does absolutely everything, maybe you spin off the manufacturing of hardware. You don't do all of it. Keep yourself small. You still have the profit potential, still own these 2 companies. You're just managing one and you let somebody else manage the other. So that is it for this presentation. Actually, not quite. For those of you that have stuck around, I have a treat. And the treat is bottle baby Kia, who's now, 4 weeks old almost? Found in my wife's car in the undercarriage when she was at the Gilroy outlets. Oh my goodness. How the hell this kitten got stuffed under by some desperate mama kitty. They found her and no mama kitty anywhere to be found. Didn't have her eyes open. She was under a week old at the time. And so Kia is named after the Kia in which she was found. And she is our lovely bottle baby. So we are a factory with a product of 1 kitten at the moment. Lots of processes going on around here. Anyway, now she's going to eat my face. Shouldn't have wakened her up, but that is your treat for sticking around. Have a good rest of your day.